Hi friends, welcome back to MS Concrete Part 16. My name is Ayan Mukherjee and I am the host of my YouTube channel MS Concrete. Today we will discuss about rebound hammer test and its calibration process. Rebound hammer is a device to measure the elastic properties or strength of concrete or rock, mainly surface hardness and penetration resistance. Renowned as the world's first NDT for concrete, the Harnett gives measure of strength. Ernst Smith patented the Smith hammer or Swiss hammer. In this test, the hardness of cement paste in concrete is measured. The instrument works on the principle that the rebound of an elastic mass impacting on a surface is a function of the hardness of the surface itself. Hence, the harder the surface, the greater is the rebound distance. Specifications are as per IS 13311 Part 2, as per BS 1881202 or STM C805 as per DIN 1048 as per China Standard GJJ T23 2001. Which influencing factors can affect on RHT? Smoothness of surface under test. Traveling and floated surfaces are harder than molded surface and tend to overestimate the strength of concrete. Size, shape and rigidity. Type of force aggregate, cement, mold of concrete. Carbonation of concrete surface. The hammer gives a powerful kick and will make marks on the test surface and chip rocks. If using the hammer or standing nearby, wear goggles. Do not use Smith hammer on anything that will break or deface. That is the safety parameter for using RHT. How it works? There are 4 phases for RHT. It is initial phase, when we have to find that proper point of that concrete surface or rock surface. Then penetration phase, we have to compress that spring. Then loading phase, we have to impact the spring. Then impact rebound, it will rebound and show some, it will measure some points. Different type of rebound hammer. Type N is a type of rebound hammer where measuring range is from 10 to 70 Newton per mm square compressive strength. For normal use below 25 MPa type, P is better suited. Impact energy will be 2.207 nm. Rebound values are recorded as a bar chart on a paper strip. Another type is NR, where measuring range is 10 to 70, same type. Impact energy also same like type N. Type L by LR. It will also measure 10 to 70 MPa. Handling and dimension as per N and NR, but with 3 times smaller impact energy, 0.735 nm. These types are used for testing thin walled, less than 100 mm or small components, but also cast stone components sensitive to impact. Another type is LB, where dimension and impact energy as for type L. The impact plunger is special design. Impact energy will be 0.735 nm. This type is used for burnt clay products. Another type is pendulum hammer type, PT by P by PN. for low strain materials, early age concrete, soft rocks, higher resolution than NL or L hammer, PT for different MPa, testing of mortar in masonry for vertical and horizontal surfaces only. This is calibration graph of rebound hammer, where we find rock pull, rebondissement and rebound R. How to calibrate? What is the procedure of rebound hammer? Before using, we have to calibrate that instrument and we have to follow some certain procedures. As per IS 13311 part 2. The procedure are the most satisfactory way to establish a controlled mass rebounds and the extent of correlation between compressive strength of concrete and its rebound number is to measure both the properties simultaneously on concrete cubes. The concrete cube specimens are held in a compressive testing machine under a fixed load, measurements of rebound number taken, and then the compressive strength determined as per IS 516-1959 bar. The fixed load required is of the order of 7 MPa when the impact energy of the hammer is about 2.2 Nm. The load should be increased for calibrating rebound hammers of greater impact energy and decreased for calibrating rebound hammers of lesser impact energy. The test specimen should be as large a mass as possible in order to minimize the size effect of the test result of a full-scale structure. 150 mm cube specimen are preferred for calibrating rebound hammers of lower impact energy, say 2.2 Nm, whereas for rebound hammers of higher impact energy, for example 30 Nm, the test cube should not be smaller than 300 mm. If the specimens are wet cured, they should immediately remove from the wet storage tank and kept for 24 hours in normal atmospheric condition. To obtain a correlation between rebound number and strength of the wet cured and wet tested cubes, it is necessary to establish correlation between the strength of wet tested cubes and the strength of dry tested cubes on which rebound readings are taken. A direct correlation between rebound numbers on wet cubes and the strength of wet cubes is not recommended. Only the vertical faces of the cubes as cast should be tested, and thus 9 readings should be taken on each of the 2 vertical faces accessible in the compressive testing machine when using the rebound hammers. The point of impact of the specimen must not be nearer an edge than 20 mm and should be not less than 20 mm from each other. The same points must not be impacted more than once. How to test? What is the test procedure of rebound hammer? First one, prior to using hammer, the surface of the concrete is first abraded with carborundum stone to remove surface irregularities. Second one, the hammer is then pushed firmly against the concrete until the trigger button is automatically released. Hand pressure is then reduced to allow plunger to fully emerge from the instrument. Third one, the hammer is then pushed firmly against the concrete until the trigger button is automatically released. Hand pressure is then reduced to allow the plunger to fully emerge from the instrument. Extra hand pressure is then applied to push the plunger back into the instrument, compressing the internal spring to a point where the trigger mechanism overrides and causes the impact force to be applied to the surface. Still applying hand pressure, the push button is pressed to lock the plunger in place, retaining the reading on the graduated scale. The strength corresponding to the reading on the scale is then noted. If concrete test cubes from the structure are available, then using the hammer on this will allow a more accurate answer to be established. How to test rebound hammer on concrete? For testing smooth, clean, dry surface to be selected. If loosely adhering scale is present, and this should be rubbed off and with a grinding wheel or stone. Rough surface resulting from incomplete compaction, loss of grout, spelled or tooled surface do not give reliable results and should be avoided. The point of impact should be at least 20 mm away from any edge or shape discontinuity. For taking a measurement, the rebound hammer should be held at right angles to the surface of the concrete mortar or member. The test can thus be conducted horizontally on vertical surfaces or vertically upwards or downwards on horizontal surfaces. If the situation demands, the rebound hammer can be held at intermediate angles also, but in each case the rebound hammer needs to be calibrated. Rebound hammer test is conducted around all the points of observation on all accessible faces of the structural element. Concrete surfaces are truly clean before taking any measurement. Around each point of observation, 6 readings of rebound indicators are taken, and average of these readings after deleting outliers as per IS 8900 becomes the rebound index for the point of observation. The variation of strength of a properly calibrated hammer may lie between 15% and plus minus 20%. Thank you. This is the end of part 16.